Hi everyone, welcome to Vedantu NEET English. I am Diksha Kaushal, your chemistry master teacher. So everybody, let me know in the chat box if I am clearly visible and audible to all of you. Hello Asina, Paki, Adina, how are you all, everybody? So today we are going to do limiting reagent and empirical formula and mass, and these two topics are like very important for you, right? They are like I would say it's not like they are not asked, they don't ask this question, or this is not important for you, or I would say, ma'am, this is like mole concept, ma'am, it is very difficult, there is no as such formula. First thing is, this is important, you take out previous year questions of the latest years, right? These, based on these two topics, they are asking the questions like continuously. Then is it tough? Not at all. It's very simple. If you understand this, I'll tell you that for sure, guaranteed that you will get marks out of this, right? Because if you talk about mole concept, there is not as such formula based on it, right? They can make it as tough as possible. But in these two cases, even tough questions, you will find it easy, right? Okay, everybody. Hello, Chintu, Jaya, Abhijit. Yes. So, shall we start the class, everybody? And how many of you did the homework? Let me see in the chat box. How many of you did the homework? Let me show you that. How many of you did the homework? First is Cheese, then Anonymous. Anonymous, please kindly tell us your name, right? Then Future IITian, that is Ria has done her homework. Sangeeta has done her homework. Priya is saying hello to Manoj. I don't know which Manoj she is saying hello to, right? So then there is Manoj Kumar, I think. Guys, what's this? Dating app? So, ma'am, who will teach organic part? Manoj is asking. So, see, I am only going to teach a organic part. That's why, firstly, we are keeping it like first we will talk about some basic concepts, then we'll study structure of atom, then periodicity, then chemical bonding, and after that, the door of organic chemistry will open, right? Then only, because once you do these 4 chapters, right, I can pick up any chapter and you will be able to understand that, right? So that's why I'm going with that flow, right? Just have patience and trust me, you are going to love it, right? Okay. Yes, everybody. Hello, Omkar. Hello, Hema. Yes. So let us start the session. The session is about limiting reagent. Okay. So how many of you understand that what is limiting reagent? Yes, what is limiting reagent? So let's understand this with the help of that you are preparing rasam rice, or what do you want to prepare? You are preparing burger buns. Okay, you are preparing burger buns, you are preparing rasam rice, anything you are preparing, right? Now we know that, let's take an example of burger buns, right? So you are preparing burger buns, that means you have a burger, you have some patty or tikki or bun inside it, right? So that is there. Now this is a hot dog, or you can say this is the burger, anything you want to talk about, right? Whatever. Now you will feel hungry after this, right? Now this is your bun, right? You have tikki, you have patties, you have anything that you want to put into that burger, right? Now how many burgers you have? That is 1, 2, 3, 4, 5 burgers you have. And how many patties you have? 1, 2, 3, 4, right? That means I'll be able to make this. Usually happens in our home, right? We are buying something, we have, let's say, stock of 4 tikkis and we have 5 burgers, right? We know that one burger is going to remain empty. We are not going to have proper burger tikki there, right? So we are only going to have simple burger where there will be no patty inside it, right? Now we know that when these two will combine, you will have a proper burger. When these two will combine, you will have a burger. These two will combine, you will have a burger. These two will combine, you will have a burger. But this will remain in excess, right? So that means this was the extra part. And this was the limiting part which we do not have. This is responsible that we are not able to make 5 burger buns, right? So this is your limiting reagent, right? So two things we have. One is excess thing, one is limiting thing, right? So just like I showed you, you are making burgers with patties inside it. So if you have, let's say if you have only 3 patties, no, let's say you have only 3 burgers, right? Now tell me what is going to be your limiting reagent. Now guys, tell me what is going to be your limiting reagent. So if you see this here, if you have just 3 burgers here, right, that means only 3 burger patties you are going to form. 2 will be totally empty here. Now, can I say that in this case, which is going to be my limiting reagent, students? Which is going to be my limiting reagent, everybody? Is this your limiting reagent or this your limiting reagent? Right? This, let's say, is your burger, right? And this is patty, right? Now, I am saying that you have 3 burgers, you have 5 patties. We know that combining these two, we are only going to form 3 burger patties, right? 3 burger patties we are going to form. Now, will the remaining will change or not? Will the remaining change or not? Yes. Now, this is actually something which is left, which is in limit, which we don't have extra, right? So, this is something that is extra. This is something that is extra. And this is something which is we don't have, because of which we are not able to form the 5 patties here, 5 burger patties here. So, now this will be your limiting reagent, right? This is in general case. Same thing happens when we talk about any reaction, okay? So you have one reactant, you have second reactant, right? Both of them are reacting to give you a product, right? Now, if this I am taking, see, we know that, let's take an example that you need two, let's take one example that you need 1 mole of A reacts with 1 mole of B to give 1 mole of C. If in the question they give me, this is 2 moles, this is 2 moles, this is 1 mole, right? Then which is your limiting reagent, right? In this case, which is going to be your limiting reagent? If you see this here, this is very clear that in this case, if 1 mole is reacting with 1 mole, then if you have 2 moles, it needs 2 moles here as well, right? If 1 mole is reacting with 1 mole, then 2 moles will react with 2 moles. That means, can I say this one is the extra thing that we are having? Can I say this one is the extra thing we are having? And this is your limiting reagent. Why? Because 1 mole was reacting with 1 mole to give 1 mole of product. Now here you have 2 moles, out of which only 1 mole will react, right? What will happen here? Out of this 2 moles, only 1 mole will react, and here out of 1 mole will react, and you will have 1 mole of carbon, 1 mole of C here, right? So that is in a reaction your limiting reagent, right? Everybody clear? Right? What is limiting reagent? Clear NEET 2025, but still will watch the lectures. Awesome, right? That's great. So, is that clear, everybody? What is your limiting reagent? The reactant which is completely consumed during a reaction. This is completely consumed is known as the limiting reagent, which is which is putting a limit to the product formation, right? If it was also 2, this is also 2, then we could have formed 2 moles of 2 moles of C. But because this is 1, that's why this is limiting the product formation. And because this is excess, this is the leftover, that's why this is called extra reagent. Okay, everybody? Yes, everyone. Okay. Now, let's talk about a method of doing limiting reagent. Okay. So, this is a very like interesting thing. For example, you have A, this is B, this gives rise to C, right? Okay. So in A, what you have, let's say this is 3 moles, right? Let's say this is 4 moles, right? Let's say you have a reaction, okay? I'm talking about a reaction. Let's say you have a reaction 2A plus 3B give rise to 4C plus 5D. This is your reaction, okay? So in this reaction, they are asking that find the limiting reagent. They will give you some hints regarding that. Always you have to follow this procedure, right? So what is the procedure that we are going to choose? So first is Gopika ma'am is smart. Okay, do you agree? Gopika ma'am is smart. Same thing we are going to do here, right? Gopika ma'am is smart. So we are going to take the ratio of G and S. G for Gopika ma'am, S for smart, right? Now, if you see this here, G means given. What is given to you in the question, right? What is given to you in the question? This means stoichiometry. This means stoichiometry. Now, if you talk about ma'am, what will be given in the question? In the question, they will give you, let's say, I am taking one random example here. They are saying that you have 3 moles of A and 5 moles of B. This is given in the question. This will be given in the question. How many moles of A you are using, how many moles of B you are using, right? Now, stoichiometry is what you have written here. This is 2 and this is 3. Okay. Now, what you will do is, you will take the ratio of G by S here. G by S is 3 by 2. Here it is 5 by 3. Now you will find that which value is lower here, right? You will find it out that which value is lower here, right? The value which is lower is going to be your limiting reagent. Yes, everybody? Okay. Everyone. So if you see this value, this is going to be 1.5, this is going to be 1.66 something, right? So we clearly can see this is the lower value. So lower value, the smaller value is going to be your limiting reagent. So in this question, we can say that A is limiting reagent. Okay, you can say this here that A is limiting reagent. Now, in all the questions you are going to solve in the same way that you will find it out what is the limiting reagent. Then you will find that this is the limiting reagent. How you will find it with the same process, right? Now, second question that might arise in your mind is, ma'am, after this, what are the other things that they can ask you in the exam, right? See, they can ask you, first thing is, which of the following is the limiting reagent? First question. Second question that they can ask you, that this is the limiting reagent, but tell us about how much amount of C is formed with this particular number. How much amount of D products, how much amount of products are formed. So same way, whenever they are asking you anything regarding product as well, how much amount of product is formed, how you will solve it. You will firstly solve the limiting reagent, and always remember, limiting product formation depends on limiting reagent. Product formation depends on limiting reagent. The amount of limiting reagent that you have will define the product that is formed, right? Now, okay, let's see this here. You will make 3 burger buns. This is defined by the limiting reagent because you had 3 burgers. Before, if you see the example that I have taken before, in this case, we know that how many burger buns we were forming? 4 burger buns. Because limiting reagent was 1, 2, 3, 4. That means the product formation is dependent on the amount of limiting reagent. So whenever any reaction, any question is given to you, you will firstly see that what is the limiting reagent, then you can answer anything about the products. Okay, guys, shall we do the questions based on this? Right? Let's do the questions, okay? I have picked up some really interesting limiting reagent questions for you. Okay, let's start. First question on your screen. Always remember, try to solve it yourself as well. Firstly, try to understand the statement here, what they are saying. First is, when 22.4 liters of H2, okay, firstly, always write the reaction H2 is mixed with some liter of Cl2 at STP, the moles of HCl formed. Now, if you remember, whenever we write the stoichiometry, the reaction has to be balanced. The reaction has to be balanced. So always remember, whenever we are going to solve the question, firstly balance the reaction. So here we know that when you balance it, it is going to be 2HCl, right? First step is balancing the reaction. Second step is, tell me who is going to tell you that this is a question of limiting reagent. Ma'am, because you are teaching limiting reagent, so that's why it is a question of limiting reagent. No, tell me in the exam how you will tell me that this is a question of limiting reagent. That is also a very important thing. You know how to apply limiting reagent, but you don't know, ma'am, there is nothing written about limiting reagent. To solve it by limiting reagent, nothing is written. Then how will you predict that this is a question of limiting reagent, not a stoichiometry? Because stoichiometry questions are also given in the similar manner. Some reaction will be given to you. Hints regarding calculation of moles will be given to you. That is a question of stoichiometry. So limiting reagent, very interesting thing is, whenever the question is regarding stoichiometry, at least one of the reactant, they will not give you the moles of one of the reactant, at least one of the reactant. But when we talk about limiting reagent, all the reactants, you will be able to solve the moles of all the reactants that are given to you in the question. So let's see this here. This is the reaction. They have given me this much liters of H2, that is 22.4 liter of H2. They have given me 11.2 liter of Cl2. That means I can easily calculate the number of moles of H2 here. That is going to be 22.4 divided by 22.4, that is 1. I can easily calculate the number of moles of Cl2 here, that is 11.2 divided by 22.4, given volume by molar volume. Number of moles formula, right? So number of moles of Cl2 is going to be 1 by 2, that is 0.5. Right? That means if I am able to calculate regarding this reaction, I am able to calculate this moles, I am able to calculate the moles of all the reactants that are present here. It confirms that it is a question of limiting reagent. Okay? First talk was that how can ma'am how you can say, ma'am, this is a question of limiting reagent because of this particular thing. Now, once you have calculated, we will apply the same method of limiting reagent here. What we used to do before, that is this thing. Now, guys, tell me one thing, right? This is the question, right? Let me just divide this page into two so that you're able to, answer it more efficiently. So, this is H2 plus Cl2 give rise to 2HCl. I told you we are going to do G by S. G by S. So firstly, tell me what is given in the question. In the question, it is given that this much of H2 and this much of Cl2 is mixed. That means 1 mole of H2 and 0.5 mole of Cl2 is mixed. That means in the given statement, you have 1 mole of H2, you have 1 by 2 of Cl2. What is stoichiometry, ma'am? What is stoichiometry here? What is stoichiometry here? Stoichiometry is one here, in the balanced chemical reaction. You will get to know about the stoichiometry. This is one, this is one. Now you have to do G by S and you will find the lower value of that. So G by S is going to be, this is 1 by 1, this is 1 by 1 by 2, that is nothing but it is going to be 2. Now what is the lower value, guys? What is the lower value? This is the lower value and this is going to be your limiting reagent. So can I say which is the limiting reagent? H2 is the limiting reagent. H2 is limiting reagent in this particular question. Now tell me, are you able to find the limiting reagent? No issues, Ramya. Yes. Yes. This is the last second lecture of chapter. Right after that, we are going to do POC and law of chemical equivalence, and the chapter will be finished. Okay. Yes. Is that clear, everybody? This is 1 by 1. That is your limiting reagent, and this is H is the limiting reagent because it is the lower value here, right? Now, product formation will depend upon which thing? It will depend upon the limiting reagent. So this is the product. They are saying that the moles of HCl formed is equal to. Now you will apply unitary method, right, in mole formation. You will know that product formation depends upon the limiting reagent. That means this thing, right? So what I will do here is, if product formation depends upon the mole, product formation depends upon the limiting reagent. So I can say 1 mole of, in the balanced chemical equation, 1 mole of H2 gives 2 mole of HCl, right? That means, can I say that if I am saying that 1 mole of H2 will give you 2 mole of HCl, so can I write it like this? Here you have 1 mole only, right? H2 in given is 1 mole only. So that means amount of HCl formed is 2 mole. So answer will be 2 mole is the correct answer, right? Okay. Why 1 mole you are saying? See, we know that the limiting reagent will define the product. Okay. So here the limiting reagent is coming out to be H2, right? Limiting reagent is coming out to be, wait a minute. G by S, no? No. You are right. Limiting reagent is not this. This is G by S, no? So this will be 1 by 2 divided by S, that is 1. So it is 1 by 2 only. So this is the lower value. This is the limiting reagent. So here we can say Cl2 is the limiting reagent. Cl2 is the limiting reagent. That means this is going to be dependent on the product formation will depend on the HCl. HCl will depend on Cl2, not H2, right? So now we can say, apply unitary method here. 1 mole of Cl2 gives 2 mole of HCl. 2 mole of HCl. But in the given condition, you have 0.5 mole. So you can say 0.5 mole of HCl will be 2 into 0.5 of HCl, that is 2 into 1 by 2 of HCl, that is nothing but 1 mole of HCl. So answer is going to be, you have 1 mole of HCl in the end, right? Because Cl2 is the limiting reagent, okay? So if you calculate limiting reagent true, automatically everything is going to change here, right? Okay, students, let's move to the second question here. That is going to be second question here, guys. Who have difficulty in understanding the first question, this will make it more clear to you, right? Okay. That is 10 gram of hydrogen and oxygen were filled in a steel vessel. Okay. So you have 10 gram of H2 and O2 that is filled in a steel vessel. We know that this is the balanced chemical equation. Okay. Now, if you say what is given and what is stoichiometry. Given is 10 gram of hydrogen. So 10 gram means 10 by hydrogen is 2, molar mass of hydrogen is 2, hydrogen atom is 1, hydrogen molecule is 2, na? So this will be 10 by 2. For oxygen, it is 64 and O2 is 32. So it is going to be 2 mole and this is going to be 10 by 2, that is 5 mole. So we can say for H2, the given moles are 5 mole, the O2, the given moles are 2 moles. Okay. Now, what is the stoichiometry here? Stoichiometry is 1 here, so I'll write 1. Stoichiometry is half here, so I'll write half. Now you have to write down the value of G by S. Here it is 5, G by S, 5 by 1. Here it is 2 divided by 1 by 2, that is this thing. And it is going to be 4. Now, which is the lower value? Which is the lower value, guys? This is the lower value. So, can I say that this is the lower value? That means lower value. That means O2 is the limiting reagent. Right? So, can I confirm that O2 is the limiting reagent here? Is it confirmed that O2 is the limiting reagent here? Yes, everybody. O2 is going to be the limiting reagent here. Now, once you know that O2 is the limiting reagent, we can directly say that if O2 is the limiting reagent, so everything is going to depend on O2. That means product formation will be linked to O2 here. So, I can say that 1 or you can say half mole of, you can write it your own way, that half mole of, or you can say 0.5 of O2 will give you 1 mole of H2. 1 mole of H2, right? So 1 mole of O2 will be 1 divided by 0.5 of H2, right? Then how many moles of O2 will be in 2 moles of O2? Acha, because originally O2 is given to be 2, right? In the given question, number of moles of O2 is 2. So 2 moles of O2 will produce how much amount of water? 2 moles of O2 will produce how much amount of water? So you can say 2 moles of O2 will give 1 by 0.5 multiplied by 2. That is nothing but 1 by 1 by 2. This is 2 into 2. That is nothing but 4 moles of H2O. Now, they are asking you the amount of water. They are not asking you the moles of water. Amount of water means if number of moles of water is coming out to be 4 moles, then we know that water is nothing but 18 is the molar mass. Given mass is, let's say, m. So mass of water is going to be 18 into 4. Right? Okay, everybody? Yes, students? Yes, students? Everyone, is that clear? How we are going to do this? Right? So answer is going to be 72 grams is your mass of water that is produced in this case. Yes, everyone. Beta, please tell me if that is clear or not. Right? Okay. Now let's move ahead. Next question is, how many moles of lead chloride? Okay, so now we are going to talk about how many moles of lead chloride. Now, those students who are finding it difficult to understand the question, right, of limiting reagent, I'll go very slowly in this question. Okay, again try to understand. Right, the more questions you understand, more you will feel that what is exactly happening. Firstly, write down the balanced chemical equation. So, how many moles of lead 2 chloride? Lead 2 chloride means PbCl2 will form a reaction between, that means the reaction is between PbO and HCl, and there we are saying that you are going to form PbCl2, right? This is what we are forming here, right? Okay, for that you need to tell me what is the balanced chemical reaction, right? If you see Pb is 1, if I solve it here, this is, let's say, H2O, water is released here, right? So Pp and Cl, H and 2, This is kind of a displacement reaction, right? So in this case, if you see Pb is 1, Pb is 1, Cl is 2, here also it need to be 2, right? Here oxygen is 1, oxygen is 1, right? Everything is sorted, right? Everything is sorted. Now, you have written a balanced chemical equation, right? You have written a balanced chemical equation. Next step is G by S. Given, you have to find out how many moles in given of reactants, how many moles of stoichiometry. So if you talk about given here, given is how many moles of lead chloride will be formed from a reaction between 6.5 of 6.5 gram of PbO and 3.2 gram of HCl. So now students, let me know how do you find the moles of PbO? Yes, everybody. Yes, everybody. How do you find the moles of PbO? Stoichiometry is already given to you. Stoichiometry, you tell me, what is the stoichiometry? Here it is 1, here it is 2. So it will be 1, it will be 2. This thing is blank here. This thing is blank, so let's find it out, right? So let's find the number of moles of PbO. Let's find the number of moles of HCl here. Say number of moles of PbO will be 6.5. 6.5 divided by mass of PbO, right? Oxygen is 16 and this is 207 plus 16, 6 to 12, 13, 2, 2, 2, 3, 2, 2, 3. So it is going to be 2, 2, 3. So you can directly put it here. 2, 2, 3 is going to be the mass here, 2, 2, 3. Then what is the number of moles of HCl? So if you talk about HCl, that is 3.2. 3.2. H is 1. This is 35.5. That is nothing but 36.5. Now tell me what is going to be the number of moles of PbO and number of moles of HCl. Yes, everybody. Number of moles of PbO, if you see this here, that is 6.5 divided by 223, that is something, okay, and here it is 3.2 divided by 36.5. So it is going to be 0.029, hai na? 0.029, and this is coming out to be 0.08, right? It is, we can take the approximate here, right? Because we don't know, need to find it as such like in full detail, right? This is number of moles, that is 0.02, this is 0.08, right? Now I'll just write it here. This is coming out to be 0.02, this is 0.08. Now you find out the value of G by S. This is 0.02 divided by 1, that is nothing but 0.02 only. This is 0.02 divided by 2, that is nothing but 0.04. Now we can see the lower is this one. This is the lower one, so we can say this is your limiting reagent, right? Once you have find it pure limiting reagent, other things are going to be as simple because they are asking you PbCl2. So directly you can solve the value of PbCl2 here by saying that you can directly solve it here. That if you see 1 mole of PbO, you can even write it here only. Okay? See, number of moles of PbO and PbCl2 are same, right? How they are same, guys? How the number of moles of PbO and PbCl2 are same? Because 1 mole is giving 1 mole of PbCl2. So you can say 1 mole of PbO is giving you 1 mole of PbCl2. So 0.029 mole of PbO will give you 0.029 mole of PbCl2. So number of moles of PbCl2 is going to be 0.029 moles. That is going to be your final answer here, right? Okay. That is going to be your final answer here. The number of moles of PbO that you have gained here, that amount is same as your PbCl2 because the stoichiometry value is same here. Okay? Yes, everyone. Is that clear? Okay. Now we have the last question of limiting reagent. After that, we are going to start with empirical formula. This was asked in NEET 2024. Right? The question says that 1 gram of sodium hydroxide was treated with 25 milliliter of this. Okay. So again, the question is sodium hydroxide was treated with HCl, right? HCl and NaOH were treated. Simple is here you will have the formation of NaCl plus water, right? Now, if you see this here, 1 gram of sodium hydroxide. If sodium hydroxide is 1 gram, then number of moles of sodium hydroxide is going to be 1 by sodium is 23, NaOH, sodium is 23, this is 16, this is 1, 6, 7, this is 10, and it is going to be 40. So answer is 1 by 40 here. So here number of moles is 1 by 40, that is given to you, right? Number of moles you are calculating for NaOH is 1 by 40. What about number of moles of treated with 25 milliliter of 0.5? So molarity is given here. Again, you have to calculate number of moles. So guys, we know that molarity is equals to number of moles divided by volume in liter, right? Here the volume is given in milliliters, so that's why this will be multiplied by 1000 here, right? So number of moles you can say is equals to volume in milliliter multiplied by molarity divided by 1000. So number of moles of HCl is going to be, volume in milliliter is 25, molarity is 0.75. So 25 multiplied by 0.75 divided by 1000, right? This is nothing but, wait a minute. If you see this is 1000, this is 10. If you separate this, this will be 4, right? Now you have 0.75 divided by 40, right? This is 0.75 divided by 40, right? Or you can say 75 by 4, 75 by 4 divided by 1000. This is the value that you are having at this point, right? Solve the value of this HCl, guys, right? Solve the value, calculate the value of 75 by 4, then replace it with 3 more decimals and you will get the answer, right? So this is the number of moles of HCl, this is the number of moles of NaOH here. Let me just see what is the value that you will get after this. 75 by 4, 75 divided by 4 is nothing but 18.75 now, so it will be 18.75 divided by 1000. That is going to be nothing but it is going to be 0.01875, right? Or you can just simply say 0.018, right? So you can simply say 0.018, and this is 1 by 40. 1 divided by 40 is nothing but 0.025. Now, which is the smaller value? No, now you're not discussing the smaller value, right? Here, what is stoichiometry? Stoichiometry is 1, stoichiometry is 1. That means, can I say lower G by S is nothing but 0.018. Here G by S is 0.025. Lower value is this. So this is going to be your limiting reagent. So can I say HCl is the limiting reagent? That means HCl is the limiting reagent. You can say this here. HCl is limiting reagent. So it will be fully consumed. Limiting reagent, it will be fully consumed in the reaction. Excess reagent will be left behind. So this NaOH will be left behind. Okay. Now, we know this. Now they are asking the mass of sodium hydroxide left unreacted is equals to. Now guys, see this thing, very, very important that we are discussing this thing here. right? I'll just see, if you talk about how much, if you talk about this formula, this reaction here, that is HCl plus NaOH give rise to NaCl plus H2, right? Now, that is the reaction. Now, if you see this here, HCl and NaOH, HCl is nothing. How much amount it is formed here? How much amount of HCl is formed here? That is 0.018, right? We know that 1 mole of HCl, 1 mole of HCl is going to give, reacts with 1 mole of NaOH. This we can see from the equation, from the chemical reaction, balanced chemical reaction, that 1 mole of HCl reacts with 1 mole of NaOH. That means 0.018 mole of HCl reacts with 0.018 mole of NaOH. That means NaOH consumed will be 0.018. This is the amount of NaOH consumed. So total NaOH will be what? Total NaOH, how much amount of NaOH you took here? Total NaOH was 0.025, right? Total NaOH was 0.025. So NaOH left behind will be 0.018 minus 0.025, and here you will have your answer. It will be opposite. 0.025 minus 0.018, that will be 567, so it will be 0.007 mole. That is going to be the answer here. Yes, everybody? Okay. Yes, everyone? Clear? Guys, you should have told me that you guys are not interested in the sessions. Then I would have stopped taking the classes. I should focus on the batch only. Why am I teaching on YouTube? Right? It's okay. I'll take one class in a while and no worries on that. Why am I teaching on YouTube then? If you guys are not at all 1% interested in lectures, then we should definitely focus on only our DNA batch, right? Why to provide you free education? Is that any benefit? 0.0 na? 005, 025 is this, yes. How many of you are interested? How do I need to say this on daily basis? It just my motivation to teach you is now zero. I don't feel like teaching. This makes me question, am I not teaching good? Right? Is there some problem in my teaching? Is there some problem in my teaching? Am I not able to communicate to you guys? Am I not teaching you well? Is the content not good? I feel like resigning from this job because of you guys. I don't feel like teaching. I feel like I am not made for this job. Leave. I'm not even kidding, guys. I'm not even kidding. I have been seeing this for such a long time. It kills me to see that, I feel like I should change my profession then. I should learn something else. I should go to an offline institute. I should teach. Because in that institute or in that way in an offline platform, at least there are students who are responding. You guys don't care. You guys don't respond. You don't care about like what the teacher is saying. It's clearly we can see that. The value, um, not even value, yeah. Leave. I know I'll leave and you will forget there was some Diksha ma'am. You'll forget. You'll be like, yes, ma'am was there, but yes, fine. If you're not interested in the classes, do let me know. If you want some other teacher on this uh, channel, then do let me know. I'll resign. There will be some other teacher teaching you. Right? Don't worry. I'll resign. No worries. I'll pick out some other job. There's so many tons of jobs out there. Right? I'll do something else in life. But if you think that I am a good teacher, then respond. If you don't think that I am a good teacher, you can let me know. If I'm not able to communicate to you, if I'm not able to limiting reason, I thought of putting so much efforts, but seeing your chats, such a low, like now it will be consistent. Now I'm speaking like motivation and all. Now students will stay. 3 live watching, seriously, do I deserve that? No, I don't think so. I deserve that. For this much hard work, I don't deserve that. If you guys are not, if you don't want to be in the live classes, then let us know. If you see our videos, one student one day I was on Telegram, very like proudly that student said, ma'am, I used to watch your lecture for last 2 years. You teach excellent, ma'am. I never commented on your video. Ma'am, I never bothered. And he was very proud of it. I was like, okay. I didn't say anything to that student. Those students who were in my live Telegram, when I take Telegram lives, they know that this happened. And I was like, why this child is so proud? Someone is putting in efforts for you. Someone is teaching you when you're sitting at your home, trying to provide you the best content, and you are chilling and you're saying, I never bothered to give a comment, ma'am. I don't care about it. Huh, ma'am. So you think that is motivating? Not at all. Not at all. Now tell me, what is the motivation? Hmm. Ma'am, I was answering, yes, you were to answering. Yes, you were to answering. But it's like I have been doing this for 1 or 2 years that I see that students are just not interested. Then it makes me question myself that am I in a wrong career? Right? Am I teaching wrong? Is there something wrong in me? I start self-analyzing myself. Right? Because more than this, I can't teach you. Right? Maximum this I can teach you. Right? Maximum in this much detail, this much slow pace I can keep. Slowest pace I'm keeping here just for you guys, that every student here who is in this class is able to understand. Right? I could be teaching in a fast manner. I don't care about you understand or not. It's a YouTube platform. You understand, cool. You don't understand, it's good. You don't pay me, right? But I'm teaching you in a very slow pace. I have a class at 8 p.m. You can go and check that out. On J, I have a class at 8 p.m. I could be teaching like gar, 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 gar. And after that, at 7, I'll be relaxing after 1 hour of class. After 1 hour of class, I'll relax and take class at 8 p.m. I don't do that. I teach you for 4 or 5 hours continuously just to teach you guys. You don't even care enough to respond to the teacher. That is so not fair. Right? Sure. Now let's start with empirical and empirical mass and formula. Right? Let's finish this so that you can also get what you want right from this lecture. Right? Okay. Now I want your response in the chat box. Right? Paki, I have seen your other reply here. You don't need to be like, Chalo. Now, let's talk about empirical mass and formula, right? Now, what exactly is empirical mass, right? For example, let's talk about you have a formula of glucose, right? C6H12O6. Now, when I want to make the simplest whole number ratio of this formula, I'll divide it with 6. And what I'll get? CH2O. And students, this is your empirical formula. This is called empirical formula. And this is called molecular formula. So empirical formula is when you write the molecular formula in the simplest whole number ratio of the atoms that are there, that is called the empirical formula. Empirical formula of a compound may be described as formula that gives the simplest whole number ratio of atoms at various elements present in the molecule of the compound. Right? Simplest whole number ratio. I'll give you one more example, like you have N2O4. You divide it with 2, you will get NO2. Further, you can't simplify it, right? So this is your empirical formula of N2O4. This doesn't mean that this empirical formula do not have its own existence. See, if you talk about this CH2OH, now tell me one thing, if I talk about CH3COH, that is nothing but it is C2H4O2. When you divide it with 2, you will get the same empirical formula. That means one empirical formula could be denoting so many molecular formulas, right? This acetic acid also has CH2O empirical formula. Glucose also has same empirical formula. And if you talk about HCHO, it has its own existence, that is acetaldehyde, right? Or you can just write it here, formaldehyde, that is methanol, right? So it doesn't mean that one molecular, this empirical formula, this particular empirical formula is denoting only glucose. It is only denoting acetic acid. No. If I am saying CH2O is an empirical formula, this may be denoting glucose, this may be denoting acetic acid, this may be denoting any other molecular formula as well, right? So for one empirical formula, there can be multiple molecular formula, but for one molecular formula, there is only one empirical formula. For this molecular formula, there is no other empirical formula than this. For this molecular formula, there is no other empirical formula than this. And if you say that this is not, ma'am, let's say this empirical formula is having its own existence also. Is it having? Yes. This is a formula that is made by dividing. But if you say you have methanol, if you divide it by 1, it will give you the same empirical formula. So methanol also has the same empirical formula, right? Got it? Right? Yes. Formaldehyde. Yes, that's what I told you. That's formaldehyde, right? Now, let's see the next thing. That, ma'am, what is actually the relation here? So, I am dividing, can you see we are dividing it with some number. Here I am dividing it with 6, here I am dividing it with 2, here I am dividing it with 1. So there are different numbers that we are dividing it with, right? So that number is called N. So we can say molecular formula divided by N is equals to empirical formula. Or you can also say that empirical formula, or you can say molecular formula is equals to empirical formula N. This is your formula of, this is your relation between molecular formula and empirical formula. And what is this N? N is nothing but empirical mass, molecular mass by empirical mass. That is your N value, right? Now these two formulas you should know, and there is, just like we did the method of limiting reagent, same way we have a method of doing empirical formula and molecular formula, right? That I will show you with the help of some examples, right? Okay, no issues. So let's do this particular question, that is, AIPMT 2008 question, that is, an organic compound contains carbon, hydrogen, oxygen. So whenever you have to calculate the empirical formula, you will draw a table here. Okay, you will always draw a table here. In that table, what will happen, guys? In that table, you will write down, first is the atoms. First column, you will write down atoms. Then percentage of atoms. Then atomic mass of atoms. Then you will divide percentage and atomic mass to calculate moles. Then there will be simple whole number ratio. This is the same method that you will use always to calculate the empirical formula, right? So firstly, here we are going to talk about atoms. Here we are going to talk about percentage. Here we are going to talk about mass, that is atomic mass, right? Atomic mass. Now here percentage is nothing. We will, so for example, I'll just take this example. See, here they have given carbon, hydrogen, oxygen. So I'll write carbon, hydrogen, oxygen. Carbon is given to me, that is carbon percentage is given to be 38.71. So I'll write 38.71, but not in percentage, in grams. So if it is given 38.71 percentage, if I take the total mass percentage of this compound as 100%, then carbon, just replace this percentage with grams. Replace this percentage with grams. So that means this is the percentage of carbon and hydrogen. Right? Hydrogen is 9.67. Now, oxygen will be what? Oxygen will be 100 minus 38.71 minus 9.61. That means you will add these two. See, total I am saying is 100%. Out of this, some part is carbon, some part is hydrogen, some part is oxygen. Right? They have given you how much part is carbon, how much part is hydrogen. You have to calculate how much part is oxygen. Right? Okay. So what is, how much part is oxygen, guys? That is 100 minus this. Atomic mass is here it is 12, here it is 1, here it is 16. Okay, this is the atomic mass. Now you will calculate the moles here. Moles is nothing but it is percentage divided by mass, atomic mass. So it will be 38.71 divided by 12. This will be 9.67 divided by 1. Calculate this, this will be 38, it will be, let's see that it is going to be, you can calculate it yourself, it will be, chalo, you can't use calculator, huh? 51.68, it is coming out to be 51.68 divided by 16. Now you will convert it into simple whole number ratio. Simple ratio. That means you will divide it, you will find the lowest number, then you will divide it with the lowest number. So if I say, if I divide 38.71 divided by 12, it is coming out to be 3.29. Okay, wait a minute. So this is coming out to be, I'll just write it here. Right, we can write it here as well. It is coming out to be 3.22. Right, this is nothing but 9.67. I think this is also coming out to be 3.22. This is how it happens. Right, so 51.68 divided by 16, that is coming out to be 3.2. So it is going to be the same only. See, the best part about empirical formula is always it is going to be in some ratio. This ratio, this simplified version, this calculation that you have, this is going to be tough. But after that, it is going to be easy. Right? For NEET aspirants or for people like me who hate calculations, this part is actually the toughest part here. Otherwise, it is simple only. Right? Because this calculation is what I myself personally hate, right? So this calculation will make the question lengthy, otherwise it's simple only, right? So now you have to divide it with the smallest number, right? 3.22. This is 9.67 by 3.22. This is the smallest number, na? You'll divide it with the smallest number, 3.22. This will turn out to be 1. This will turn out to be 3. This will turn out to be 1. So answer will be CH3O. The empirical formula that you calculated here is, empirical formula is CH3O. This is the empirical formula. Now, have they given you any molecular formula here? Empirical formula, just empirical formula only they are saying. So, we already have done it. That is nothing but it is going to be CH3O, right? Empirical formula of the compound is coming out to be CH3O. They can also ask you the empirical mass. For empirical mass, you can add 12 plus 3 plus 16 and that is going to be your empirical mass. Okay, so that was about simple question. Now let's see, ma'am, is it repeated even now, ma'am? This is such a old question, right? Yes, it is repeated even now. You can see in NEET 2021, it was repeated. An organic compound contains 78% by weight carbon. So again, we'll do the same thing. What is that? We'll firstly have a big table on this, right? So from that table only we are going to solve it, right? Now this is the atoms. This is the percentage of atoms, atomic mass, then ratio you have to calculate. Let's do that. Atom is carbon and hydrogen only. They are saying organic compound contains carbon and remaining percentage is hydrogen. So it is simple. So carbon and hydrogen only, 78% is carbon, right? So that means 22% you are left with, right? So that is your hydrogen. They are saying remaining is hydrogen. Right option for empirical formula of the compound. We know that atomic mass for carbon is 12, for hydrogen is 1. So here it will be 78 by 12. This is not exactly going like this is not exactly cutting it, but it will be, I think, 6 point something, right? So to exactly do this, you have to calculate this, right? It will be 6 point something because 12 into 6 will cancel out it. So it will be 4 zeros. I think 6.4 shayad. Let me see. 78 divided by 6.5. Yes, it will be 6.5. Right? So 6 point something, we can guess an idea about it. This will be 22. Now the smallest value is this, so it will be 6.5 divided by 6.5. It will be 22 divided by 6.5. Right? This is coming out to be 1. Now 22 divided by 6.5 you have to calculate. Okay. 3.38, which is not at all coming out to be a simple whole number ratio. Right? That means the empirical formula is not a simple whole number ratio, right? It is coming out to be 3.38. Now what to do, right? Now what to do? So what we will do, because we need to make it into a simple whole number ratio, what we will do, we will not go into points only, right? Because we need to have it in a simple whole number ratio, right? So this is 78 by 12. Rather than doing this, it will be 12 to 6. This will be, because I need to make it into a simple whole number ratio, I need to do that, right? So this will be 2 into 3. This is 9, right? So it will be 39 by 3, right? This is 2, 3. This is 18. So it will be 9. So 3 into 2. And this is 3, 1 into 3. So it is 13 by 2. This is 22. So if I multiply this by 2, so this will be 2 cancel, this will be 13, this is going to be 44. Right? Yes. So they have taken a very approximation they have used here. because exact number we can't get here. Exact number, it's not coming. This is 13, C13, H44. So you can, if you divide this by 13, if you divide this also by 13, then 44 by 13, right? That is coming out to be 3.38. So it's an approximation thing only, guys. Because otherwise here also we are not getting a simple number. It's this number that you are getting, right? So this number is not a simple number, right? You need to have a simple whole number ratio here, right? So that's why we'll divide it with 13. It will be 1. This is going to be 13. This will be 3.38, which is approximately 3 only. So this also depends on the options, okay? Otherwise, the ratio is coming out to be C13H44 only. But if this is not, if this is given in the question, in the option, this will be more accurate, right? But this is not a simple whole number ratio, right? So the simplest version, nearly simplest version is CH3 because it is 3.3. So we are calculating it as 3, right? So this is not the exact value. This is like nearest value, right? Okay. Okay. Existence or empirical formula is not an existence. Empirical formula is not in existence, guys. Empirical formula is the simplest ratio. Just you have 8 divided by 4, the ratio is 2. Similar thing, you have the ratio, that is empirical formula, right? Okay. Now, next is, wait a minute. Next is this question, that is compound A contains 8.7. Now they are saying compound A contains 8.7% of hydrogen, carbon, nitrogen. Molecular formula of the compound is this. Okay, so firstly we'll have to calculate the empirical formula. So hydrogen is 8.7. You can see this table here. I'll just show you directly, right? So you can see this table here. This is the percentage of carbon, nitrogen, oxygen given in carbon, nitrogen, hydrogen. This is hydrogen, carbon and nitrogen that is given, right? So this you will directly put. Atomic mass, you know, here it is atomic mass is 12, here it is 14, here it is 1. So you will divide it 74 by 12, 17.3 by 14, 8.7 by 1. Now, whenever something, first you have to divide it with the simple whole number ratio, right? So now this is coming out to be 1.2, this is coming out to be 6.16, right? Now divide it with the smallest number here, that is 1.23. So 1.23 you divide it, this will be 1, you divide it with 1.23, this is 5, this is 7. So that means empirical formula is coming out to be this. See, empirical formula is coming out to be C5H5NH7. Okay. So can I say what is the empirical weight here? What is empirical mass? That is 12 into 5 plus 14 plus 7, right? That will, after solving, will come out to be 81, right? Now we know that to calculate the molecular mass, what we have? N is equals to molar mass by empirical mass. Molar mass in the question will be given to you, that is 162, right? So it is 162 by 81, that is nothing but 2. So molecular formula is also empirical formula 2, that is nothing but C5, that will be C10N2H40. That is going to be the answer for molecular formula here, right? Okay. So that is going to be the answer. Answer is D is the correct answer here. Last question of today, that is empirical formula of a compound is CH2O and its vapor density is given to you. See, whenever vapor density is given to you, so indirectly they have given you the molar mass. The simple thing is here they have given you the empirical formula. If they want to make the question really lengthy, you will have to firstly find out the, let's say, this is how you will find out the empirical formula. right? After that, they give you vapor density to calculate the molecular mass, right? So 2 into vapor density is your molecular mass, right? You can see molecular mass is nothing but 2 into vapor density. Vapor density is given to be 30, so molecular weight is going to be 60, right? Now molecular weight you already know, right? Empirical weight you can calculate. Empirical mass will be 12 plus 2 plus 16, that is nothing but 30. Molecular weight is nothing but 2 into vapor density, that is 60. So N is equals to molecular weight by empirical weight, that is nothing but 60 by 30, that is 2. So molecular formula is going to be, empirical formula is CH2O. This is 2, so it will be C2H4O2. So answer is going to be D is the correct answer here. But the relation between vapor density and molecular formula you should know. Right, everybody? Okay. Thank you. Thank you so much, Sriyani. Thank you so much. Thank you so much, yaar. Chalo, I hope so. Then I don't know. I to still question myself sometimes, right? Sometimes when you are like, I'm asking, is that clear? When you guys don't respond, then I question, have I even taught right or not? Right? Because as a teacher, my inner self is always asking me that the future of these kids is in your hands. So don't teach them wrong, or don't, you know, don't let any student in the class feel like that they are not able to understand anything or they are not good enough, right? So I try my best to make things as simple as possible. I don't know if it is coming out to be simple or not, right? If it is coming out to be simple, that would be great. If it's not coming out to be simple, then you can let me know so that I can also improve myself, right? Okay, yes. So guys, this is your homework. First homework is find the simplest formula of compound with this. Molecular formula is this, compound is this. Molecular mass is given molecular formula. You have to tell. This is your first question for your homework. Then next is, this is the second question for your homework based on limiting reagent. This is based on limiting reagent. Okay. Consider the above reaction, limiting reagent of reactions and number of moles of NH3 formed. So this is a question based on limiting reagent. You have to answer me this. This is a question based on empirical mass and formula. Okay. So guys, that's it for today. And I want you guys to do the homework, right? I'm waiting for your homework in the comment section. Also, let me know if you want me to make a DPP on some basic concepts of chemistry or not. Do let me know about it. And guys, this is our official Telegram channel of NEET, right? You can go and follow it because all the updates regarding NEETs are given here. And guys, this is, wait a minute, let me just show you. If you see this in the description box, yes, over here, in the description box, if you see this, right, here you will see for all the NEET 2027 aspirants at this point for the pro course, 20,000 off is going on the courses, right? And 10,000 off is going on for NEET 2026 aspirant, right? And if you talk about DNA batch 2026, that is at 4999 at this point, where we are providing you live classes, doubt sessions, leaderboards, quizzes, mock tests, and whatnot. Test series are given to you, modules are given to you. I don't know, so many things at just 4999, right? So you can just purchase it by clicking on view now, and the batch is totally going to be in English, right? Here you can see that this prime batch with all the things that I told you will be provided to you. If you talk about 5999 batch, where these kind of QR cards will be provided to you, right? These kind of QR cards. And if you talk about 6999, the QR cards plus the AITS All India Test Series will be provided to you, right? Okay. Thank you so much. I watched your lectures last year, but I stopped to watch your lectures because when the NEET, when you were just 5 months to go, you said, okay, you said you cannot do nothing. You cannot do nothing. Huh? You start from zero at that time. Uh, have I told you something like that? No, I never disappoint my students, huh? I never disappoint my students. I genuinely feel that you can crack NEET even in 3 months, 4 months, right? If your basics are clear, right? Only if your basics are clear, right? If your basics are like good and you have not like properly started preparing for NEET, you can crack it. But for that, you have to be very, very disciplined, like next level discipline, right? But yes, if it's like your basics are also not clear, I'll be very blunt, guys. If your basics are not clear, right? The concepts, even basics like what is electronegativity, which is ionization enthalpy, that is also not clear, right? Then one subject you can do in 3 months, one subject you can do like perfect. Maybe chemistry and bio also you can do perfectly. But in 3 months, physics also along with that, I doubt that, right? If you're a really scholar, then definitely you can do that, right? Okay. I don't know then why I said that, right? So, yes, okay then, students. Till then, bye bye. Take care. Now I'll see you all in the next class. Bye bye. Take care. See you all. Bye bye.